Serious? Very good. Okay. So let's continue. So we start looking at EasyBuild. Let's take a look at the features it has. So the main idea behind EasyBuild is that it fully automates the process of building and installing scientific software. So you can fully autonomously build stuff, even if it has interactive installers, like word traffic. It also takes care of dependency resolution. So if you're trying to install something that has missing dependencies, EasyBuild will install the dependencies first for you, and then continue. It also takes care of generating module files. We'll get back to module files. So it both takes care of the installation and making sure that users can access it easily. It logs everything it does, all commands are executed, which environment they are being run in, and so on. So you can later, for an existing installation, get back to how it was installed in EasyBuild and check on things. If something is working properly, or you want to make sure that it was built correctly, you can actually go back and check it quite easily. When something is installed, it archives the build specification, the easy config file, which I'll explain later. So with the intention that you can easily reproduce an existing installation later on, maybe on another system, or maybe you want to do a simple version update and you want to make sure that the installation is the same as was before. EasyBuild is highly configurable. There's very little in it that's hard coded, so you can set things with lots of configuration settings. It supports configuration files, and binding variables, and command options. Every configuration setting is available in all three levels. It can be extended dynamically, so you can add support for more software, add support for more compilers and VI, without having to reinstall EasyBuild. You just tell EasyBuild support the needs there, pick it up, and use it whenever you have to. It also supports custom naming schemes for modules. So you can name your modules any way you like. It does something by default, of course. You get full control over how you can name. You can also do hierarchical modules, and I'll explain that later on. You can see what EasyBuild will do, how it will install a particular software package without it actually doing the installation. You can do driver installation in a matter of seconds and just check what it's going to do, to make sure it will do things the way you expect it to. We do lots of testing. There's a big test suite included in the EasyBuild core. We also do regression testing, so every time we have a new release, we try to make sure that all installations that worked before still work with the new release. It's a good thing we have clusters to release tests on, otherwise it's going to take a while. As I already mentioned, the development is very active and have frequent stable releases every couple of weeks typically. We have a new release. It's also a tool for collaborating between various HPC stacks. So, for example, the UX Supercomputing Center is also very actively using EasyBuild. It's also contributing back to it. So it's not a tool only maintained by us, but it's really a community behind it. And the community is worldwide. We have people in the US, Europe, even Asia, Australia, using and contributing back to it. So it's important to mention what EasyBuild is not. So it's meant to be a replacement for tools like Make or Snake or any existing build tools you have. It basically wraps around them. So if your software is being installed with Make, EasyBuild will just call Make for you. So you don't have to rewrite the way you install it. It's also not a replacement for package managers like Yum. So It basically is just a tool on the side, and it still uses some packages that are installed with package managers. They just tries to build all the same software from source, also the dependencies and so on, to fully optimize. It doesn't replace the normal applications. It's also not a magic solution. So even though it automates a lot of things, it makes things a lot easier. It doesn't mean that everything is always going to work out of the box. You will still run into compiler errors. It doesn't solve that for you. But it does help a lot in the sense that if somebody figured out once what the problem was and fixed it in EasyBuild, then other people use that solution as well without even knowing it. There's lots of tricks and details in EasyBuild that even I forgot about, but things just work. And if they don't work, they can be fixed by somebody and everybody benefits. EasyBuild is or can be or already is the uniform interface to install software. So no matter what the software is using, whether it's using CNA, whether it's a Python package, whether it's something very complex like Word to install, when you're talking to EasyBuild, you're always doing the same thing. You're telling EasyBuild, install this software, this version, this compiler and API, these libraries, this version of the dependencies can go. So it's always the same workflow, no matter what the software is using. Which is, of course, a big part of why it's a lot easier to install software. Because it automates this whole workflow, it's a huge time saver as well. I mean, Alexander was just telling me over the coffee break that in Unity, for example, they can easily update 75 packages in a single day, building everything from source, just because EasyBuild takes care of all the automation, all the fiddly stuff, doing things in the right order, checking on things where everything's in place, generating modules and so on. So it takes away a lot of the boring and repetitive tasks. Because it does things always in the same way, it also gives the users a very consistent software stack. Everything's installed in the same. So it makes it easier for users to find things or to make sense of how things are installed. It's not because George installs something today and then Andreas installs something tomorrow that users have to know who installed it and have to use things differently. No. It will make sure that everything's very consistent. It's an expert system for software installation because we have lots of collaborations, people figuring out problems or figuring out suboptimal things in EasyBuild to do things now. So fix it themselves. It gets contributed back in EasyBuild and basically everybody benefits. So there's lots of things in there that may be important to get good performance or to get a good installation that you may not know about. And because of that, it's a platform for collaboration between HPC sites. It can also help users if that's something that the users are ready for, or that you want to support to self-manage their own software. So because EasyBuild doesn't need admin privileges, you can basically install software anywhere. You can just tell EasyBuild, please install there in your home directory or in another file system and patch system. Users can install software easily themselves. Maybe not all recommended to, because then, of course, they are in charge of maintaining their software stack. But in some cases, it makes sense. If they're doing modifications to existing software and they want to have that build of that software themselves, they can quite easily do it in EasyBuild without having to get to know the details of how to make and how to use the compilers, how to link to these and these libraries that are being recommended. They can also only install the stuff that they are customizing and just use everything else that is centrally installed. So installations can be spread across multiple places. So in terms of supported software, so for most of the common slides, there will be a link included with more details. So on this page, you can get a full list of all the supported software. I'm not going to mention all of that. We'll take a little bit too much time. But there's well over 1,000 software tools and applications. A big part of these are scientific software, also all dependencies and tools required to build and use these are included. So some of the big applications that are included are and that take a lot of time to install by hand, or Chrome, WRF, CPUK, so some of the big applications. In addition to these over 1,000, it also includes support for installing hundreds of hardware-based Python packages and so on. And typically, or one way to install them is to For example, for Python, you can install maybe 30 or 40 Python packages are installed as a part of the Python installation itself. So when users load the Python module and start using Python, stuff like NumPy, SciPy is just there. You don't really care where it is. So you don't have to load additional modules to get all that. If you want to, you can also install them separately, maybe for version updates. The toolchain support, I'll get back to toolchains later. It's basically compilers, API, and Blast layback libraries. It's getting very diverse as well. So of course, GCC and Intel are there. You can also use Clang as a toolchain compiler. PGM is there. There's not a whole lot of software that's being tested with PGM, and at least the basic support is there. You can try to build software with PGM. So IBM Excel is there, the basic support, but there's one side in Texas really using this, but it's not really included in the central EasyBuild repository yet. And you can also use the gray compilers. API or the classic API libraries are supported. For Blast layback, we have Intel and KL and OpenBlast are at least according to me, the go-to libraries nowadays. But also others like Atlas, HTML, so the AMD library for the gradient side. A little bit of terminology, you'll hear some of these terms, and we already have heard them as bars, so what to explain this. So the EasyBuild framework, what we call the framework, is really the core and the heart of EasyBuild. So that's where all the logic is, where all the functionality is that you need to install software or send software. So it includes things like the function to compact articles, the function to apply patch files, run shell commands and check the exit code, collecting output. It also has the logic of how installation procedure looks like. So you start by getting the sources, unpacking the sources, going into the build directory, run, configure, build, install, maybe test and install additional Python packages and so on. So all that general logic is included in the EasyBuild framework. It's basically a collection of Python modules and packages which are organized in some way. Typically, you don't really need to know really much about this. EasyBlock, so we call it EasyBlock, is basically a Python module. You can see it as a Python script, which is used as a kind of plugin to the EasyBuild framework. So this Python module basically implements one particular build and install procedure. This may be a very generic procedure like configure, make, install, which you can use for other things. Or it may be very specific, for example, for a Wharf, you have a dedicated EasyBlock to install. Just install Word to talk to this interactive configure script. You need to run the custom compile script they have. That's it. An easy config file, and then a build specification. I'll show these config files detailed a little bit later. So this basically tells EasyBuild which software package you want to install, which version, which toolchain you want to use, which dependencies, and which versions of dependencies are being used. Toolchain or compiler toolchain, I already mentioned, it's basically a set of compilers, typically C, C++, and Fortran, with a bunch of libraries on top of it, typically MPI, Blast data, and support is included in the toolchain. And then extensions, so these are the Python packages that it's installed. In addition, R libraries, all these things, we refer to them as extensions in general. So they are not standalone packages, they typically are a plugin or a library or something else. So to get a short or a quick idea of how big EasyBuild is, some numbers. So there's about in the EasyBuild framework and the EasyBlocks, together with the library that supports option parsing grouping, there's about 50,000 lines of Python, which is not a whole lot, but it's big enough that you have to be careful to organize them well. In addition, we have about 15,000 lines of tests. So every time we change something, we fix a bug in EasyBuild, or we add a new feature, we try and make sure we add a test code as well. So we'll need to verify that it's actually working as it's supposed to, but also that we know that we're not going to break it in the future. So we try very hard to basically block implementation of new features and test missing. because we know it's going to backfire on us everywhere if we don't have a test. Lots of supported software, so this is the exact number for the latest EasyBuild release. We have 25 different tool chains, so different combinations of compilers, API, layback libraries. They are available out of the box that you can start using. And of course, for each of these tools, we have different generations and versions. The easy blocks that are included, so the largest part of them are software specific. So, for example, Word, it's a software specific easy block. We have 30 generic easy blocks for standard installation mechanisms like configure, quick install, CA, quick install, and so on. And one thing to note here is that with these 210 easy blocks in total, we can support over 1,000 applications. So that means that for 181 of these, so basically, let's say 10–50%, we have a software-specific easy block. Everything else is supported with generic easy block. So there's a lot of code review going on. There's a lot of generic easy blocks that get used for lots of software applications. For example, the configure make easy block is used by 400 or 500 of these applications. So that, these are the easy ones, of course, but they are out of the box. The EasyBuild release, the latest one, includes almost 7,000 easy code files. These are the build specifications. These tell EasyBuild install the software this version, this tool chain, these dependencies, and each one of these are tested. So basically, this combination of versions works. Then, of course, if you want to, you can use your own easy configs on top of this. So that's a first look at EasyBuild. Now, one of the problems we ran into after using EasyBuild for a while is that we had lots of software installations. And we needed to have an easy way to let people actually use these installations. And they can see them on the file system, but how do you actually use the software that's there? How do you set up your environment or set up your job and you can actually even use the software? So some of the issues that are specific to how scientific software is installed is that, well, first of all, it's a wide range of scientific domains, so you can't just make everything available all the time. So people will be using Python 2, others will be using Python 3, so there's no default version for any tool that really works for the whole cluster. So you need to be able to let users pick some. Also, lots of different versions, lots of different builds, and maybe even variants of the same software are installed, and typically also with different generations of compilers. So you recompile things if there's a new compiler version to get the best performance. Typically, software is installed in a non-standard location. So if you try to use the commands by default, they will already be there. You have to prepare your environment and update, for example, the path variables so you can find the binaries. Make sure maybe that the library path is set, so the libraries that are required by the binaries can be found. So this environment changes that you need to do, you don't really want to expose this to users because it's too complex for them. Especially if they're not familiar with Linux, they don't have no idea what you're talking about, what environment variables are, or what even libraries are. In addition, some settings could be software specific. So for some software, you would have to say, this is where you find your data, or this is where you find your plugins. For Python, you have the Python path, environment variable, which may be important for these places to work. So this is a key issue of HPC clusters. It's not new, it's been there since forever. And as I already mentioned, a modules tool is a well-established solution for this. So it basically organizes the mess that we provide to users. What the environment module does, it basically, for each software installation, you get a component module file, which is like a sort of script to set up the environment. Now, it's not a script in the traditional sense, because the script is shell agnostic. So if you're using a bash shell, or a TC shell, or maybe fish, or whatever favorite shell you have, the same module file works regardless of the shell. And typically, at least in the traditional environment modules tool, these scripts are written in Tcl, so it's a specific scripting language. The users don't use these module files directly, but they talk to the user interface, which is the model command. And I'll show that in the video later. So this is used on basically, I don't want to say all HPC systems, but over 80% for sure. So we got some numbers on this during a ball session at Supercomputing, so certainly more than 80%, probably 90-95%. If you go to an HPC system, the model command tool will be there, and you will find lots of models. And it's been there for a very long time. So typically people use the traditional environment models tool is table-based. Didn't include the link here, actually. But if you Google environment models, you will end up on some SourceForge website which has environment models tool. It works, it still works. Lots of sites are still using this, but it's no longer actively maintained. So the standard implementation is a combination of Pickle and C. The release was December 2012. This is already getting a little bit old. And this was a bug fix release. The fix for the bug that we reported because of EasyBuild. And the release before that was also like 2 years. So your Pickle version, which seems to be actively maintained, but I think it's like 2000. Don't see any in your Pickle.
I can comment on that because I know one of the maintainers from CA, French,
so you guys have the
so they are maintaining it and using it with CA. And we are discussing whether to use it also in PRACE in cooperation with these 6.
Okay. Let me convince you not to do that. Okay.
I will give an email and talk to them about we switched to Almond recently and he still wants to do it. So, but I can, well, sure, you're from Ken and he's from Paris. It's not so far.
It will be interesting to talk to you. And especially if he has arguments for their implementation compared to Almond, I'm very interested. Okay. So yeah, it's being actively maintained, and at least some sites are using it, which is good. But in my view, as far as I know, it lacks in features compared to Almond. So just so people know, the model's a little bit better. So I hope most of you already know, but so the user interface works like this. So people can check which models are available, which models are available. So this is how they know which software is available. If they want to start using a particular installation, they go to the corresponding module, which prepares the environment that they are in for using that software. They can check which module they have loaded to the module list. They can, this is a cool feature, they can reverse the changes in the environment. So if they change their mind, they can unload the module. They basically undoes the changes to the environment. Maybe because you loaded Python 2 and made a mistake, you loaded Python 3, so you can unload Python 2 and load Python 3 instead.
What's the switch?
Sorry? Switch is this, yeah, you can swap as well. I didn't mention it here. The same. The switch is basically unload followed by a load. You should have viewed that. It's a good. And you can wipe your loaded modules to start over from scratch. It's a very intuitive way for users to change their environment. Even for people like bioinformaticians who are maybe not very IT-minded, you can quite easily explain to them just load the software and start. So as an example, for example, here I'm checking which GCC version or binary is active. So here I'm getting the OS one. It's probably outdated. I want to use one of the later versions and check which models are available for GCC. I see there's a whole bunch of versions, and I'm picking the latest one, GCC 5.3. And if I then load the module and check again, I'm suddenly getting a different GCC version. So the old Pickle-based version is, in my view, outdated. Maybe not the Pickle pure one, but let's see if it matches up in features. So the Almond is a modern environment model. It was created a couple of years ago, 5-6 years ago, I guess. It's very, very active. So the guy maintaining it, the same guys behind the exalts. It's very responsive to requests from the community, questions, and bug fixes, and so on. So he probably does a new release multiple times a week. I would guess this is already updated. So all the development is done on GitHub. It's implemented in Lua. Now, if you don't know the Lua language, it's basically there on most Linux systems because it's used by Yum, for example. RPM uses Lua, the Lua scripting language as well. So it's probably already there. LMOD is intended to be a proper replacement for the traditional tickle-based environment models tool, which are now called TMOD, equivalent to LMOD, Lua, and this is tickle. So it may be that you're using the model command already with LMOD without module. So it's the same interface we use. Actively maintained, frequent updates, very helpful community. Lots of activity there. So this is slowly taking over the HPC world. It's going slowly, but people are starting to realize that the whole tickle-based one is really good enough. So some of the highlights, same module interface. So for users who are surprised, the module files can still be written in Tickle, so you don't have to change the module files to start using LMOD. You switch to using LMOD, and it should work depending on how complex the logic is in your module file. For regular file, it works quite well. You can also use Lua as a language to write the module files, which is nicer than Tickle. And you can mix module files with both. So you can have some of them installed in Tickle, some of them are written in Tickle, some of them written in Lua, and LMOD doesn't really care, just combines things nicely. The big selling point of LMOD is that it caches module files. So one of the issues with the TMOD implementation is if you have lots of modules, things can become very slow. So user interface for checking available modules, even for loading modules, can be quite slow because it's accessing all these tiny files in the file system, typically on the shared file system, which is not ideal. This is fixed by LMOD by having a module cache. So basically, you can tell LMOD to build a cache file, which is a single file that includes all the information about all the different modules. And LMOD then queries the cache rather than talking to the module files directly, at least for some actions in the module interface. If your module available, you check the cache. If your module load, it will actually still go to the actual module file because it may be an update here in the cache. You can configure LMOD to use the cache for those or not. Makes a huge difference in response time, especially if you're using EasyBuild and have thousands of modules. If you don't have LMOD, things are going to be slow and users are going to complain. The small downside of this is if you have a cache, it has to be up to date. So you need to have something that probably like a cron job that updates the cache. Okay? How often do you update the cache? It depends how often you install software. If you only install software once a day is probably enough. If you use EasyBuild and you install 75 installations throughout the day, then maybe once a day is enough.
Then maybe you should be doing the cron job, maybe you should be doing applications too.
You can configure it manually.
Is there a centralized cache except from the user?
Yes, so there's LMOD is called the system cache, the central cache, and the best way to configure things, and I'll get back to that, is to have the system cache always active and configure LMOD in such a way that it never generates a user. The only situation where it makes sense to also have a user cache is if the user has lots of modules itself. Because the system cache can never include the user module files. But I have a specific slide of that because this is an important aspect. So in Kenneth, for example, we have a cron job that updates the cache every hour, even if there are no new installations, we just make sure the cache is up to date. And we can trigger the cache updates manually as well. If we have installed something and we don't want to waste 1 hour for the user, we can trigger it manually. It's a matter of a couple of minutes to update the cache. Together with the standard module interface, it also has a shorthand ML commands, because the module command is easy to type, as you can see here. So ML is short for module list. If it doesn't have an argument. If it has an argument, it's short for module load. So that's the genius about ML. It's both module list and module load, depending on how you use it. And all the other subcommands like avail, you can just pass an argument to ML to make it So ML is modular data focus. Once you get used to ML, there's no going back to it. We keep mistyping. So LMOD is mostly a drop-in replacement to keywords. It's not a full one-on-one match. So there are some things that you should be aware about that LMOD does differently and usually does better. So one big difference that people maybe surprised by or maybe learning is the one name. So basically with LMOD, you can only have one single module loaded for each software package. So for Python, for example, there's only one Python module that can be loaded. Only one GCC module, only one Wharf module, and so on. So LMOD doesn't allow you to have two versions of the same software loaded at the same time. Out of the box, it does this by, so say you have modules, you have the Python 2 module loaded, and then you load Python 3. What Elmo does by default is unloading Python 2 and loading Python 3, which may be what you want, but not always.
Is it a swap version?
Yeah, I know swap is basically what it does. Sure. It swaps one module, so only one. The one label, you can also enforce it in DMOD. You have to do it yourself by adding content statements in module. So you have to say Python 2 content to Python 3. You have to do this in every module file, so it gets a bit annoying. If you forget it once, then you can't have to do things with it. You can configure LMOD rather than doing this swapping to unload by default to actually print errors instead. For the user, hey, you already have Python loaded, so you can unload or swap instead. It's getting the order of software versions correct, so it doesn't sort versions alphabetically, but according to what software versions mean. So version 5.10 is newer than 5.6, which is not what people think. It has proper support for hardware modules, and I'll get back to that in detail, what that means. So basically, LMOD was created to use hardware modules because Keywords doesn't have the support. Other stuff, just very briefly, you can define families of modules. For example, you can define an API family to specify that there's only one API module that can be built. But if it's open API or API page, it doesn't make sense to build these both at the same time. So you can say only one API module. You can add properties to modules which show up in colors and modular layouts. You can say this installation is GPU aware, or maybe mark things as being beta installation. You can have sticky modules, so modules that not get unloaded or module purge unless you be forced to unload them, which can be useful. Sometimes sites have a module that should always be loaded to set up the default environment for use, which is also users can define collections of modules, so they can load several modules, organize their environment, and then use module save to give it a name, and later easily restore that same collection of modules. System administrator can deprecate modules. So if you want to get rid of all the installation, you can actually say to LMOD, every time this old module is loaded, the user should see a message like, beware, this installation is very old, it's going to be removed at the end of the year, please migrate to something else. This is very easy. It supports implementing hooks to customize the behavior. So for example, we have a hook implemented that basically spits out a log message every time the module gets loaded. So module loads which user, which module is added to syslog, and then later we collect all information so we can make graphs of which module is loaded. So this is the easy version of tracking software usage. And internally, it has good debugging. So if you run it with the -D, you will see how it all works internally, where things go. So if you want to debug something, it's quite good. So some community-related things. EasyBuild and LMOD have been growing quite fast in the last couple of years. Today, so certainly for LMOD, we claim that it's being used at hundreds of HPC sites in all across the world. For EasyBuild, I'm reasonably sure it's over 100, but it's not 100. community is getting quite big. And it's both being used on small HPC sites and very big ones. Both communities are very welcoming, very supportive, even if we're totally new to these tools and start asking stupid questions. We won't make fun of you and say, oh, read the fucking documentation. No, we'll be very helpful and try and help you out, point you to the right parts of the documentation and give you clear answers to your questions. There's also quite a bit of overlap with EasyBuild and Elmo nowadays. So we recommend the Elmo as one tool, and lots of people in the Elmo community are also using it. Active mailing list, which you should join if you're using or interested in using, or if you have any issues, let us know. EasyBuild has also an IRC and Slack channel where they can just join and start talking to us. So people using EasyBuild and Elmo are not only using it, but also contributing back, so they're reporting bugs and even requesting or implementing features, contributing back changes. So some numbers. So this is the EasyBuild mailing list. The growth over time is basically growing quite fast. And this part we're probably going to have more than 55, 60 new subscribers this year. So close to 200 subscribers. Of course, sometimes multiple people from the same site subscribe. EasyBuild messages. So last year we had over 1,000 messages on the mailing list. Certainly growing in terms of usage and in terms of what people are trying to do. Also in terms of code contributions, we're seeing quite a bit of growth. So there's 3 components to EasyBuild: the framework, so the core of EasyBuild, the EasyBlocks, so the Python scripts that implement how to install software, and then EasyConfig files to build specifications. The EasyConfig files are easiest to contribute back because you can easily build a version and then say this worked for me. The framework and EasyBlocks require some Python mods, Python coding. You get fewer contributions there, but it's getting close to 50 for both framework and EasyBlocks. And well over 100 people have contributed to EasyBlocks. Okay, that was a high-level introduction to give an idea of what the tools do. Any questions so far? Before we go into a little bit more practical stuff, yes.
The EasyBuild, does it also know how to create packages?
Yes, I'll get it. Oh, sure. Right now, yes, it can. You can create RPMs, for example, for software installation.
So it's mainly because you compare it before to creating a dev package or creating an RPM, but it's actually a build system.
Yes. So the main intention of EasyBuild is to build and install the software. To create packages, we actually call output number 2, FPM, which is Everything Package Manager. And you can just tell EasyBuild, please create a package as well, and EasyBuild just calls out FPM.
So it's like an environment around the build system to make it easier to use.
Yes.
That's what.
Yes. I'll show you some of that. We'll get a better idea. Any other questions? Okay. So let's first look at EasyBuild, how to install and configure it. So the requirements you need are not that crazy, especially not with HPC systems. Basically, a Linux x86 HPC system should work. There's a lot of testing done on Red Hat-based systems, but also people are using them SUSE, and so on. It kind of works on macOS, and all the Python code works on macOS. But we don't really test extensively or have a lot of these config files that are tested on macOS. So it's not a target platform for EasyBuild, so we focus on HPC systems. You can also use it in Windows by the new crazy Windows subsystem for Linux. Basically, you Ubuntu running in Windows. Shell. People have tested it in there, it seems to work quite well. There's some
running under ESD.
I've never tried it. I'm not sure. If you try that, so x86 is the main focus point because it's the most common HPC architecture. But people are also have ported it to ARM. So someone use it to install GCC on a Raspberry Pi? Right, okay, there you go. Yeah. So that works too. One of the guys in Europe, Marcus, is as a hobby, he's working in EasyBuild.
But he has it's not a Raspberry Pi.
No, he has another ARM board.
Yeah, he has a cluster.
Yeah, yeah. So he's playing around with that. Seems to most people. Like stuff like GCC and beyond seems to work quite well. There's a site in Texas that uses it on Power Linux as well. But that's not really computed centrally yet. That contributed centrally yet, so we're trying to work on that. You need a Python version in the OS, Python 2. The Python 2.6 or something more recent is good enough. We don't support Python 3 yet. We don't see it as a problem yet because the standard Python and most Linux distributions is still Python 2. And in any case, if that changes, if the standard changes, then Python 2 is probably not going to disappear very soon. But at some point, we'll have to start working on it. And typically, you use your system compiler, usually GCC, to start installing the toolchain, which is usually the recent version of GCC. So you need the C++ compiler. And then, of course, a modules tool, because EasyBuild talks to the modules tool to see which dependencies are available. And of course, L1 is highly recommended, and it's the default one used by EasyBuild. To install EasyBuild, so EasyBuild is a Python tool, it's a Python package, nothing really special about it. But the installation of Python packages can be quite messy. There's like virtual env, easy install, wheels nowadays, with a whole bunch of stuff to install Python packages. And we kind of got sick of explaining people, yeah, if you use this, you have to take into account this and this. So we created a bootstrap script, which is basically installing EasyBuild with EasyBuild. So on the system where EasyBuild is not available yet, you can just download the bootstrap script, tell it where to install EasyBuild, and in the end we'll get a module, the module views to make sure the module is available. You can download the EasyBuild module and you're good to go. Once you've done this first installation for later version of EasyBuild, just install EasyBuild with EasyBuild. And of course, if you want to use or prefer to use Python installers like EasyInstall or pip, maybe to install EasyBuild in the OS rather than as a module, there's nothing else. There shouldn't be a problem. There's also packaging efforts on the way for EasyBuild itself. So you can install EasyBuild as an RPM, for example. It's already there in OpenHPC. So you can find a spec file for EasyBuild in OpenHPC. And one of the Fedora packages is also working on it. I don't think it's there. To update EasyBuild, there's a couple of ways. So first of all, the new releases are fully backwards compatible. So anything that worked before will still work now. Unless we do a new major version, so the next one will be EasyBuild 4, then it's going to be very clear what changed hard and what you need to take into account if you want to start using it. Usually it's quite small, but you don't plan any big breaking things pretty soon. To update EasyBuild in different ways, you can just rebootstrap to get the model. You can tell EasyBuild to install the latest EasyBuild version, so it knows how to download that and install it. Or you can build a specific version of EasyBuild using an EasyCopy file that you can use in EasyBuild. Or you can find EasyBuild. So once you have EasyBuild, update things straightforward. To configure EasyBuild, as I already mentioned, different ways. You can use configuration files with just key values or key format, like this. Environment variables with EasyBuild underscore prefix and the variable name. So for each of the configuration options, the corresponding EasyBuild variable, and also the command line. So for every command line parameter, there's corresponding environment variable, corresponding entity configuration file. And there's no exception. Of course, these three have the hopefully very logic order that the command line overrules the environment and the environment overrules the configuration. So it's different levels of configuration. And like system level, user level, testing. By default, EasyBuild will do stuff in $home.local, which is a sort of standard. It's a weird standard to me. You have to pick some default to manage one big standard. Of course, that's not recommended typically in these PC systems. You don't want to install lots of software in a hidden directory in your home. So you should change this by configuring EasyBuild. Once you've done that, you can use the show config option to split out the current configuration. So it will split out something like this. So here we are configuring EasyBuild with an environment variable, EasyBuild prefix. We're customizing the build path to -m in order to show the configuration. And what it will do for a couple of important configuration settings, it will always include them. And then for any non-default configuration setting, it will also be included here. So for example, the prefix, and it marks with E for environment variable, because that's how we configure it. The build path will be marked with a C for command line. And some of these others just follow the prefix, so that's why you also have the E. And this one is marked D for default. So you can both see what the configuration is like and where things are to. Which can be important if something isn't where you're expected to be. You don't have to hunt down or even configure it different time. Then LMOD, to installing LMOD, it was already mentioned, it requires Lua. So Lua 5.1, 5.0 will not work, but that's very old. 5.1 or a newer version of Lua should work. It needs a couple of non-standard Lua extensions, but usually packages are available for these configuration. So these two are hard required. These two are recommended, but if they are not there, LMOD ships the version. The installation procedure is quite straightforward. Configure it install, so nothing special. It also includes some profile scripts to set up the environment for users, which you should typically include so that if people log into the system, the module command is defined, the ML command is defined, and things just work. LMOD is typically installed system-wide through a package, like a Debian file, and you typically configure it specific to your site. So it has some default configuration, of course, typically you customize it to your site. Our spec file, so the way we install LMOD is available in this repository if you want to take a look. So to configure LMOD, you can customize it when building LMOD via options to the configure script. You can also tweak it at runtime, so no matter how it was configured by default or through these configure options, you can define environment variables to make it behave differently. And then two other aspects of the configuration are two other files, Lua files. So here the LMOD.rc file tells LMOD where the cache file is that you're using, and also which properties you can define in modules. And then the hooks that you implement, for example, to track which module get loaded or any custom behavior that you want to change. By writing a small bit of Lua code, you can implement in the site package. Similar to EasyBuild, you can query the active configuration module message file. LMOD will tell you how it was configured in the site. So some of the configuration options we use. So how we change the default. One thing, and this looks surprising maybe, is to redirect messages to standard out. So informative messages should go to standard out, so you can easily pipe them to another command, like counting or whatever. The default modules tool doesn't do that. All messages go to standard error, which is sometimes confusing for users. LMOD does standard error by default as well for compatibility with tmod, but directing informative message to standard out is just the way it should be. So that's how we control it. We don't care about anything. This is how we disable LMOD to do the automatic swapping on the name clash. So if the Python is already loaded and another Python is loaded, rather than it swapping automatically between versions, it actually produces an error to tell users you can't load the same software again, you already have it active, so you want to unload the other one or swap with versions. So we like this better than doing the office swapping because that may be problematic in some cases. We set short time to a very large value. We do this to avoid further users spider cache. So this is Andreas' question. You can have different cache files, system cache files centrally, and each user can also have a user cache. The thing is, Elmot will, if it sees that it takes a long time to query the model files, it will start building a cache file automatically for the user and then save it in the home directories. Typically, at least we don't want this to happen very easily. So what we basically do is put a very high timeout for Elmo to wait. So how long it has to take to query the module files before it starts saving it to the user's cache. Because we know our system cache file is always going to be what it should. This is maybe going a little bit too deep within module versions and collections, which is not going to be focused. We also use the cache file for module loads. So we also want to have loads go faster, so not only go to the file system, but just take the modules from the cache because we know the cache system. So back to the spider cache, so this is a very important aspect of Elmot. You basically have to get this right to get a good user experience. If you don't get this right, then the model interface will be slow, like it is the theme of your if you want to have a model and all commands be responsive, you need to get this right. So a couple of details here. So the location, you have to specify it either by a configure option, via the Elmot.c file, so one of both, and then you can check how things are configured now. And like for testing, you just run module avail and it should show the models, which should be probably less than a second if you get it, no matter how many models you have. To update the cache, there's a tool that's included in EasyBuild. It's a small script that basically saves the old cache, starts building a new cache, and then it makes sure that it's an atomic operation. So you can never have a cache that is not available and it's outdated. And again, yeah, avoid using the user spider cache in the short time. Okay. Any questions on this basic installation configuration? No? Okay. So let's take a look at how to use EasyBuild mainly. So the main EasyBuild command is called EB. We like to take it short. So the way you tell EasyBuild to install a particular software version, which toolchain to use is using an EasyConfig file. So you can just on the command line you list one or more EasyConfig file names like this, and then EasyBuild will go looking for this file in the EasyBuild installation or in a certain location specified in the configuration. You can give it multiple EasyConfig file names. You can also give it a directory with EasyConfig files in it, and it will just involve EasyConfig files in sequence. To check what it's going to install, you can do -d. So for dry run, it's going to give you a list of things that will be installed for this particular Python version of this toolchain. So this is the toolchain part. Intel 2078 is basically a collection of Intel compilers, API and NPL. The latest revision we have, and this is the Python version. Maybe I can give you a short demo on how what that spits out. Let's see. Look. I should try this. So I'm going to cover this in a bit, but you can search which EasyConfig files EasyBuild has available for a particular version of Python, for example. Where there's a search. And this is very long, and it prints the full path to the EasyConfig files. If you use capital S, which is the short version of search, it will do it like this, give the location, and then give the subdirectory where things are in. So we can see Python itself. We have an EasyConfig file here. Now we have a bunch of other packages that sit on top of this Python version. So let's take a look at the dry run output. So now we're firing EasyBuild. It's going to read the EasyConfig file, parse what is in there. Personally, so it's going to check for each of the dependencies in the toolchain what is needed for that. And it's going to give us an overview. So in the end, we'll end up with a Python module for this toolchain, and everything else above that is what you need to install Python. So some of these are already there, and others which are missing the X still need to be installed. Here you also see that the toolchain itself also has an already installed. So once the module is there, you just load this. So that's the dry run. If you're happy with this, or if it's what you expect it to be, you can run EasyBuild again with the robot option. So the robot basically tells it to do all the dependencies first, anything that's missing, install it first, and then install this actual installation. The minus D here is to be able to run it. So you can chain options together like this. Something. So for each installation, EasyBuild will do this stepwise installation procedure. So all of the steps are listed here. So of course, at first it's going to read and parse these config files to figure out what to do. And then it's going to go through the installation procedure as you probably expect. So it will try to download the sources if it knows where to find stuff. And if the upstream location works, that doesn't work, or if you're not connected to the internet, it's easy to configure for you. If the source is already available locally, so EasyBuild downloads a location, you can also just put the sources there if it finds that it's happy. You're going to try to download it. Once it has the sources, it can set up the build directory and the build environment. So it's going to pack the sources, maybe apply patch files that you have specified. It's going to load modules for both the toolchain and the dependencies of the software. So everything is available in the environment that will build and install it. It's also going to define the environment, so stuff like C flags and CC based on the toolchain that is used to try and make sure the right compilers use the right compiler options that we use to install. And then it's going to do the standard configure build, maybe test, if there's a base test or something like this. Supported by the software. If that all works, you can install the software to the location that is specified in the EasyBuild configuration. If there are any extensions listed, like traditional Python packages, it will take care of it as well. So this is this step. And then once all that seems to have worked, so if all the commands work, there's no, if they all exit 0, if there were no errors detected, it will continue to do a sanity check. So this is an important part. It's a small part of an important part of EasyBuild. It will check whether the things that should be there are actually there. If you build Python, you expect to have a little Python there. You have a little Python.3 there, for example. It will check whether these files are there. Because if they are not, something is very wrong. For each of the commands that EasyBuild executes, it checks the exit codes, but that's not always right. Like for Word, for example, you can run make, it will do exit 0, I'm done, and then the thing is there, you check the log, still compile. So sometimes the people that do the build procedures don't get things right there on the exit code of the line. The sanity check helps with catching all of this stuff. If the sanity check works, then it's going to generate a module file. So we're basically next to the software installation, you're going to have a module file, and then you can load the software and enjoy it. Each of these steps can be customized, so either you can specify parameters in the EasyConfig file, for example, configure options for the main command, and so on, if you have to. And very often this is done in the EasyBuild. For example, for Word, you fully specify how to run the configure commands in the EasyBuild itself. If you run EB with doing an actual installation, it looks like this. First of all, it's going to create a log file. If something fails, you can just dive in there and figure out what's wrong. Hopefully. And then it starts reading the config file, parsing it, figures out which module it has to install. So for this, it queries which module naming scheme is active. So you may make this lowercase or add something to the module name if you want to. It's up to you. And it will go through each of the steps. If it's happy with the sanity check, you can create a module. make sure permissions are correct. Here it can do packaging, so it can generate RPM for the installation that was performed, which will include the model file as well. After all that is done, it copies the log file to the installation directory, so you can find it later. And then the document is complete.
Can you show an example of the practice installation in some directories that you want? Not the default, not TMP?
This is not TMP. Here it's installing to opt EasyBuild. So EasyBuild here was configured to install to opt. You can,
If I want to install on the press.
sure, you can, the location that the software is installed to is on your computer. You configure EasyBuild to install to submit. So here, for example, you could do EB, the name of the EasyBuild file, then dash prefix /EB or /alt or whatever. It's a full, you have full control.
And it not requires root privilege.
So the only thing you have to do, you have to write permissions to the location. That's all. So any user can install something.
What about licenses software, for example, individual compilers and so on?
It can install digital compilers as well. Of course, you have to provide the license file to use it. It looks in, so for Intel specifically, it does a lot of things. It looks in license files in your home directory. And it also checks the Intel _ license file environment file. If it sees that, you can pick it up and assume that's a correct license file for Intel. It will give it to the installer, start installing. So that's also supported.
If I can chip in here, we have a dedicated, in our case, you can do it as you want. In our case, we have a user that is dedicated for building software. We call it a build user. And all of these options that Kenneth mentioned, you can have as an environment where. So when you go into that user to build software, all the clippings and all of those settings that you have, where you want to be building the software, where you want to be installing the software, and all of those things are in that user's environment. Actually, we take it a step further, but we could do that, right? And then you don't have to worry about setting that up in the command line and making a mistake on that.
You can set up the default configuration like you want, and EasyBuild picks it up and installs it. So here, EasyBuild was configured to install to opt. And whoever is running this, of course, has right access to this location.
The only one thing that we have to do the access outside for repositories of EasyBuild. Because every source has to be downloaded.
Yeah, well, EasyBuild doesn't take care of that. It downloads just from the upstream sources. So that's what it does by default. But say if you're building on a system that doesn't have internet access, you can just download the sources yourself somewhere else, put them in the location where EasyBuild looks. And the first thing EasyBuild will do is it starts building GCC in the source path. You can configure that. It will check for the toggle for GCC. If it finds it there, it will use that from back. So even if you're building on a host that doesn't have internet access, you can still do it. We don't take care of the sources. So there's no EasyBuild repository of all the sources of the software. We just pick it from upstream or search it on those tasks like for Intel compilers, for example. If you don't you have to give it to the installation.
Seems like a magic.
It's called easy, not a solution. Let's take a closer look at EasyConfig files. So these are the build specifications. You can basically build them as text files with key value definitions of the parameters. They're written in Python syntax. At least in the current version, we're trying to go to a YAML syntax, but we're not really there yet. So some parameters have to be specified. Which software, which version, which toolchain you want to use. We also enforce that you specify a home page and a short description of the software, which then gets included in the module file that's generated. And then other parameters, which are strictly speaking not mandatory but are often used, are which EasyBuild should be using for the software, which sources are required, maybe also patch files, which build and runtime dependencies should be there, maybe options to configure build and install commands. You can specify these in EasyConfig file as well. And then also for the sanity check, which files should be there once the installation is complete. An example is copy file here is for more, for example. This is basically a complete one. If you give this to EasyBuild, it will do this installation. Everything else it knows already. So here are a couple of things: the software version, the software metadata, so these are hard required. Also, which toolchain we're going to use. So in this case, the Intel toolchain is a particular version, which means a particular version of the compilers and API and so on. Which sources and patches. I trimmed this a little bit, but basically what's important is there. We tell EasyBuild this is the format of the source terminal, the name of the source terminal, so it will include the version, the software name, so Word and here version nationwide is basically 3.8. Because apparently the tarball doesn't have it. This is where EasyBuild can download the sources if it doesn't have it yet. And we also tell it to apply a patch file, which is basically a patch file for the bugs that are reported on the website and say, change this to this. We create a patch file for that. And then EasyBuild should be using the EasyBuild dependencies. So one important thing here, note that all these versions are fixed. So EasyBuild will use these specific versions of the dependencies, not something else. That's a key difference with another installation tool, which I'll briefly cover at the end. All versions are fixed. So if you give this easy copy file to somebody else, they will get the exact same installation, same dependency versions, same toolchain, same compilers, same board versions. For more specifically, we also have this custom parameter, dmpar. This is one of the variants that you can build on board. It's basically a distributed build, so an API installation. This is one of the questions you have to answer in the configuration. What kind of build do you want? EasyBuild custom that it doesn't guess. And one detail here, we don't specify an easy block here, which basically tells EasyBuild there's no generic easy block we're using, it's software specific. With no easy block that's specified here, it knows I need an easy block specific for Word and those reports. Any questions on this? Yes.
EasyBuild by itself, it pre-compiled or have to compile this?
It doesn't do any pre-compiled stuff. It builds a process.
For example, I have some process and some nodes with different operation systems. So for every operation system, for example, on page 6 or page 7, I have to compile EasyBuild in different way because it
Yes, yeah, that's typically what we do. Strictly speaking, it's not 100% necessary because you could use the installations or let's say Red Hat 6 also on Red Hat 7. So typically, they have a different cluster, it also has different architecture, different processors. Like Intel has one of the sandwiches. You really want to build your software for that architecture to get the best performance. Like Intel has one has ADXP instructions, which are not there on sandwich. So if you use the installation for sandwich from Haswell, you will use it before. The EasyBuild is easy, you just push the button, build it, and you know, or use the disk space on your side.
EasyBuild, we can use PRACE too and put it on your unit test.
Sure, yeah, you can do it. But EasyBuild itself, you don't have to compile. It's using the installations done with EasyBuild.
For example, one day before leaving Israel, I compiled for my user GLOMAX. It takes for me last version of GLOMAX, it takes for me 4 hours compilation with this. What about the EasyBuild? How
EasyBuild includes support for GLOMAX. I don't know if the latest version is there. So it's not even the recent version. I was installing software all the way here. Like in year, what was the support request?
how much time it takes?
It was 2 minutes. It was, yeah, I was checking the version of the software, updating this number, and the easy config file, and doing the installation. If we see the mail within 5 minutes, we can do this in 5 minutes. If the software is already supported, sometimes it's not supported. Yeah, it works. Okay. Let's continue because we're running 20 minutes, running out of time. There's a couple of more advanced features I want to mention. So the log files, I already briefly mentioned this. It totally logs everything that's being done, so you can maybe get back to it. So how is EasyBuild configured? Which EasyComfort file was used? How does it look like? Which modules were loaded? Which versions of dependencies and toolchain? How does the environment defined where the build was performed? Which command were executed and what was the output, and so on. Everything is there. You can get back to it. The log file is copied in the installation, so you don't lose it. And maybe later you want to get back to it in case something isn't where you're supposed to be. Also, of course, when the build fails and it happens. So sometimes if you do version updates, you think, oh, it's just going to be the same installation as before. So maybe they changed something. Then you have to go in and try and figure it out. This is how a log file looks like. It's all structured and timestamped. So forwarded messages like I'm running a config set now. This is the command I'm running. I'm running it in this location. This is the output. Exit code 0. If it's a non-zero exit code, this will stop there and say something. To add support for software that is not there yet, or software versions that are not there yet. So for every software installation, you need an EasyBuild file. It's a simple version doc. You need to either copy an existing EasyBuild file, change the version, update the version, or we also have command line options for this. You can try software version, and EasyBuild creates an EasyBuild file, changes the version, and hopefully download any sources and go load the source. So you don't even have to hand create or hand update the EasyBuild file. But you do need the EasyBuild file for every installation. It's well covered in the documentation. If it's totally new software, you also need to figure out which EasyBlock EasyBuild will have to use. If it's a standard package like configure it and install, you just tell EasyBuild to use this EasyBlock. It knows how to do it. You give it the right configuration options maybe, and it continues. If it's something very complex like Word, and this is something we'll have to do soon for TensorFlow, for example, which is using this Basel build tool, which is new intention investment. I'm not pretty sure. But for TensorFlow, we would have to create a software-specific EasyBlock. It's not standard enough to use in generic one. This requires writing some Python code. It has some good documentation as well. Some generic EasyBlocks that we use a lot. So I already mentioned configure make, which is used for 400 or 500 of the tools we support. Standard configure make we install. Of course, configure get the prefix where things need to go, and you can add your own configuration options quite easily. CMake make is another common one, same as configure make, but using CMake rather than configure script. Python packages have their own EasyBlock, so you can tell it in the Python setup file install, or use Pip, or use any of the 100,000 other Python defaults. Make CP is used a lot for bioinformatics software. It doesn't have configure commands. It has a make file, but they don't have a make install target, so you just run make, and there's a you typically want to copy out the binary to bin so directly. It's nice and clean. Maybe also copy some other example file. Let's make CP, and the tarball is just unpacking the tarball, copy everything. That's for typically binary installations, or just a question of raw scripts or anything that doesn't need it building. And binary is used for binary installers. For example, Intel compilers are sort of installed by EasyBuild. There's lots of others. We have, I think, 30 generic EasyBuilds now for standards build procedure. So there's a little bit of a thin line between EasyCopy files and EasyBlock. When do you really need an EasyCopy? When do you get get away with an EasyCopy file? It kind of depends on how clean or dirty you want to use this. So there's a lot of flexibility you get in EasyCopy files. Configure options are something you can certainly specify in EasyCopy file. But sometimes you have people hacking around, trying to convince EasyBuild to do something while it's actually better to write EasyBlock. The downside is for writing EasyBlocks, you need to have some Python knowledge, you know a little bit about the EasyBuild framework, how to talk to it. of some signs that you may need an EasyBlock or some critical values for EasyBuild and EasyConfig parameters for things to work. Maybe also configure options. If you're building the data compilers, then you have to tell it, I'm using the compilers. And rather than making sure you get that right and get the EasyConfig file, you do it once, EasyBlock, and you will get it right. Also for dependencies, same story. If you have to run interactive commands, you basically have to implement it EasyBlock so you can tell it for this much you can this out. The common toolchains, so the concept of toolchain is not really clear. For people new to EasyBuild, it's sometimes hard to pick a toolchain what you start with. So we have these two toolchains that we recommend. The Intel toolchain, which is all Intel tools, compilers, API, and KL. We also have a FOSS toolchain, which is short for free and open source software. So it's basically the GCC based with OpenAPI, OpenClass, so if you don't have an Intel compiler's license, you can certainly use the FOSS toolchain. You can now look at a particular web to be able to install it. These are the two ones we recommend. They are also most used in the EasyBuild community. So you have lots of config files using these toolchains. You want to reuse the efforts, but done by other HPC sites and also help other HPC sites. These are the toolchains. The installation procedure that EasyBuild will install, you can get a quick view of what it will do in a matter of seconds using the extended driver. Basically, what it will do, it will show everything that it's planning to do without actually doing it. So it won't even unpack the sources for you. It will just unpack the sources and go into this directory, run this command, configure the area, make install. I'm going to expect that these files are there for the sanity check, and this is how the model will work. So it gives you a quick idea of how things will work.
There, it doesn't exist as EasyBuild stuff.
No, it creates it. So this driver is very useful when debugging EasyBox, for example, changing EasyConfig files. If you change something, you want to check on how it's reflected in EasyBuild. You can get a quick idea. So this is a request that we really don't need because we know enough about EasyBuild to predict on how it's going to install things. But for some users, EasyBuild was too much of a black box. It was working, but they couldn't really figure out, or it was too much effort to figure out what it was doing. So this was implemented basically by request in the community. Give a quick idea of how it looks. So this is the output for Morph. -X or extended driver is the same thing. It will just tell, I'm going to use this EasyConfig file, so location. I'm going to use this EasyBlock, which is in this location, so you can actually dive into the EasyBlock yourself if you want to. This is the module I'm going to install. I'm going to use these potential download URLs. This is the download I will need, and if I download it, this is the location I will put it in. So if you are on a node that doesn't have internet access, you can put it there yourself. To continue, so skipping to the build step, it's telling you which command it's going to run in which location. And for the sanity check, it's going to expect that these files are there. If they are not there, it's going to display and stop. And then at the end, it also shows you if I end up generating the module, this is how it will look. It gives you really all the details, and this runs in seconds no matter which software you specify. It's basically skipping all the actual work. So this is very good stuff. To use a custom naming scheme, so EasyBuild uses a naming scheme out of the box, which is standard. I don't know if it's standard, but it's the name of the software / the version, the toolchain, and maybe a version suffix. So this is for build variants like the DMPAR, WARF, DMPAR will be mentioned. It has a couple of other naming schemes that you can use, and you can implement your own naming scheme relatively easy. It's a small Python module that you implement that says, for this EasyConfig file, this is how the module makes it work. You can basically construct it yourself. you're not happy with the default. So flat versus hierarchical naming scheme. So a flat naming scheme means that all the modules you install are available all the time for the users. This can be confusing because not all modules are compatible with each other. Something installed with GCC 4, you can only combine it with something installed with GCC 5, for example. These have to be very careful. Also, in a flat naming scheme, the module names can be quite long. It's software version, toolchain, and the users don't really understand what toolchains are. So, in a hierarchical naming scheme, things are organized differently. You build like a tree of modules. And then you have to load one module to make more compatible modules of things. And typically, this is used in a core compiler organization. So this looks something like this. So this is a representation of the modules that the user sees. So the light gray ones are not visible to the user. If you module available, they are not there. The blue ones are available. So in this case, the only models that the user sees initially are 2 versions of GCC, and nothing else seems to be there. There are other modules there. They don't show up in the output of module there, but especially with LMOD, you can search through the whole set of module files using module spider. It's like a search option. So people can figure out what is there, but just use spider. Now, how this works is when you pick a compiler, when you load one of these modules, suddenly other modules become available. So these 2 OpenAPI versions were built with this version of GCC. This should be blue. So blue for only this one is loaded at this point. So this opens up like another box of modules that users can suddenly use. And all of the modules that are available at this point are compatible with each other, as long as they have a different. So this GCC can be combined with this version of OpenAPI. Users don't have to be scared that they are loading incompatible modules at the same time. OpenAPI modules, now the comments are okay. These 2 are loaded, which opens up another box of compatibility. So things are organized in a different way, and note that the module names are nice and short. You don't have to tell in the module anymore which toolchain these were built with, because it's implied by the location. So things are nice and short, and people can only load compatible modules. That's the idea behind hierarchical module names. But actually using this in practice is a little bit more complex. And organizing your models in this way can be quite tricky. You have to know really how this works. The good news is that EasyBuild knows about this naming scheme. You can just tell EasyBuild organize the models hierarchically, and it does it for you. It gets all the details right to make sure that it's working properly. Yeah.
Let's need faster transform 335.
Yeah, this one.
How am I able to understand which models I need to load?
Yeah, this is what spider is for. So this command, module spider, we module spider FFTW335, and spider will tell you, this module exists, but you have to load this GCC and this OpenAPI first.
You will give me all the possibilities.
Yes.
I mean, MDR, 110.
Yes, exactly. You have to load, it will tell you have to load this combination, GCC 5.3 with OpenAPI 2.1, or this with this, or this with this, or this with this. Because the module for this one is in 2 locations. So you basically get 4 modules.
GCC 6.
Yeah, 6. Yeah, so it's spider 2 will tell you. So this is a different way of organizing things. Whether this is good for your user or not, it's not 100% clear because you're forcing users to load a compiler and an API. Okay, what the compiler is, depends. You can also just load the default form. If they log into the system, they have GCC and an API loaded. All those that we care about scientific applications. So there's a middle ground there somewhere, and if he's letting that's short on. You don't confuse users with these toolchains and these subjects. For more details on this, there's a paper that I'm going to mention at the end. I will rush a little bit for the last couple of slides. So one other thing EasyBuild includes is GitHub integration. We use this a lot for testing contributions. So the easy config files that are included in EasyBuild are just available straight away. But if some easy config files are only available in the repository upstream in GitHub, we can actually just pull them in straight from the EasyBuild command line. We can do from pull request from PR, we give it a pull request number, and basically tell EasyBuild, yeah, this new stuff I won't distribute even though we don't have it locally. We just pull it in from GitHub to start installing. We can upload test reports for things we test with people who open a pull request with us. We can upload a test report to say, hey, this worked for me too. So it's probably a good idea to merge this. You can even create contributions on the command. You can create pull requests, you can update existing pull requests straight from the EasyBuild command. This saves quite a bit of time because you don't need to know all the Git magic anymore. EasyBuild does it for you. And even for experienced contributors, there's like to make a contribution, you have to start a new Git branch, you have to add a file for every Git commit, push to GitHub, log into GitHub, click on the pull request interface, open the pull request. New PR does that for you. So it's just a single command, and you can easily make a contribution. This was fun to implement to time saver. Some other features that weren't covered, I won't go into detail here, but the packaging support, for example, is mentioned here. This was one of the questions. You can submit installations to a cluster as jobs, as individual jobs for each of the installations, and EasyBuild will order things correctly, so you can like parallelize the installation. We support RPath linking as well. Users can install their own modules if they want to. You can do partial installations, like only regenerate a module file. That makes sense. EasyBuild is supported on PRACE systems as well. That's relevant for people. So the people at CSCS in Switzerland are relying heavily on EasyBuild on their PRACE systems. Contributing back is maybe a little bit too far, but we have good documentation how to contribute back as well. And we don't only consider code contributions, but also any feedback, bug reports, questions. That's all contributing back, so we're very open to all of that. To close, so how many people here have heard about SPAC? 1, 2, 3. I should have asked this question in the beginning, but how many people have heard about EasyBuild before I started talking? More. So SPAC is also an installation tool. They call it, it's more a package manager. It's how they're calling it, at least for scientific software in HPC. It's more recent than EasyBuild. So when we started EasyBuild, this wasn't there yet. This is like 2, maybe 3 years. It's developed by somebody at Northern Livermore. And it has really grown a lot in the last couple of months as well. It's sort of similar to EasyBuild. It's also implemented in Python 2. They also generate modules. So they do certain things in a very similar way. They also have the concept of easy blocks, they call it packages, package files. It's quite similar. There's a couple of key differences to EasyBuild. So we fix all versions of dependencies and toolchain and make sure things are really useful for other people. They have a more flexible approach. So on the SPAC command line, you can say EasyBuild install GrowMax version 5.1 with GCC and everything else, figure it out. So SPAC will just fill in the gaps, like, I need this, I know I need this dependency, they're not asking for a specific version, I will just use this version I know about. Same for GCC, if you don't care about the GCC version, I'm going to use the latest 6.2 or 6.3 or whatever. So that's very useful for software developers, but for user support teams or people that want to reproduce installation that somebody else did, this is really not what you do. So according to me, and I think Dot agreed with me on that, is that the focus for SPAC is more on software developers. So people who develop large applications and to juggle with a lot of dependencies and to test on different compilers, different API versions. For them, it's very useful. For the user support teams that need to deliver lots of software to users, maybe EasyBuild is effective. But it's up to you. I've been trying to work with Dot to get a good side-by-side comparison of both tools online. About 10 years, but we're definitely talking about it. Same here, similar to exalted OGRT, we are not fighting with Slack, we're talking with them all the time, we join each other's conf calls. We go out for beer together. So it's good to have some competition and to get some of their ideas and see if we can use them all the way around. To round up, there's a couple of papers that you may want to read up on EasyBuild. Some are in combination with Common as well. So the first one explains in detail about the module hierarchies, how it works, and how you can use EasyBuild and Helmut to install software like this. The second one is with the people from CSCS, explain how important EasyBuild to PRACE systems. And then the last one is also from the guys in UWIC, so from Marcus, David, and Alexander's colleagues, that explain how they use EasyBuild on a large system. If you want to do Reka, this is a reason. Other than that, I'm done and I'm happy to take any questions. Yes?
Mail with the link of this presentation.
Sure, but I think Stilos is going to upload it to the program location, so I'm happy to see you. Yes.
About more generic version definition, I would put the toolchains or modules itself, because, for example, we know that, let's say, okay, let's take some example, 2.7.9 would be the same function as 2.7.8, but just something, or maybe that is something new, but still it's, better than 2.7.8. To remove the dependency or the need to compile two versions, 1.5 and 2.7.0 and 2.7.9. So if you say, okay, if I have Python with 2.7.0, then my 0.8 or 0.9 or 0.7, if they are compatible. Because otherwise, if you combine several, let's say, tools or toolchains, even toolchains and then libraries, you end up in a never-ending combination just to support one version of software, right? And this is, I think, the biggest consequence.
So the version fixing is it's both easy and it don't cause problems. Like if something that is good with things, has to be a little bit technical. We thought about it, sure, but it's not an easy problem. I mean, just allowing EasyBuild to pick up 2.7.star and it figures out the star basically what's available. That's not too hard, but then you have to be very careful what you do. Because if you suddenly install a new Python version, then anything you install later on, suddenly be some new Python version, you may not be what you want to do. It also makes it harder for sharing these files. Because for Python, it's probably okay if you have 2.7 something, and then it's not fully true, because you may have a bug in 2.7.5 that prevents you from installing something, but it works fine with 2.7.9. So it has a couple of side effects that we thought about it, sure, we should put the house to manage.
Yes, so now my question is, considering this model.
Considering, yes, the time to actually do it is so this is more than the spec. They are very flexible, you can do partial specification of what you actually need to build, and then spec things on it. So there it's support. For toolchains, we kind of already support that. So toolchains are also in levels. You can compile it on the toolchain, compile an API, or compile it behind reply libraries. You can install something on different levels as well. Like if you already support EasyBuild, it will look across the different levels, and if it's one of the levels, but we're not playing with toolchain sets. Considering it, sure, we need somebody who has like probably a couple of weeks to figure out implementation and all the side effects. So it's not something we say, no, it's a bad idea. It's just the fixing is very easy. Implementing that is easy. Either you look at the model is there. If you start to become flexible, there's lots of things left and right. Any other questions? Yes, people are hungry. Don't hesitate if you see me throughout the week. If you have any more questions, if people want to get the slides, maybe Steve has already uploaded them. I can soon get them to you. Thanks a lot and have fun throughout the rest of the week.
have those.